Hello, this is Dr. Grande. Welcome to my video on conducting a log linear analysis in SPSS. Log linear analysis is used to analyze 3 or more categorical variables, and it's an extension of the chi-square test. Log linear analysis is used to determine the least complex model that best explains the variance in observed frequencies. So taking a look at these fictitious data I have loaded in the data view here in SPSS, you can see I have 3 categorical variables: treatment, gender, and outcome. All 3 of these are dichotomous, so treatment has group counseling and treatment as usual, gender, male and female, and outcome, successful and unsuccessful. So if these data were collected from a counseling research study, we would have a treatment and 2 levels, and gender 2 levels, and we would be looking at the outcome to see if the participant was successful or unsuccessful in the treatment. Now, it's important to recognize in log linear analysis that we do not specify a variable as an independent variable or a dependent variable. All variables are treated equally in log linear analysis. However, depending on how we set up our research study, we're going to know what we intend the outcome variable to be. Of course, in this case, it's named outcome. It's whether they're successful or unsuccessful in treatment. But as far as the analysis, no distinction is made between the variables. Observations in a log linear analysis must be independent. No more than 20% of the cells can have an expected frequency less than 5, and all of the cells must have expected frequencies greater than 1. In terms of the assumptions for log linear analysis, it's also important to recognize that if one or both of the cell count assumptions are violated, the result will be a significant loss of statistical power. That is, the ability to detect a difference that's actually there. So let's move forward with log linear analysis. I'm going to go to Analyze, and then Log Linear, and I'm going to go to Model Selection. And this is what the model selection dialog looks like by default. All 3 variables are of interest to me, so I'm going to move all 3 over to the Factors list box here on the right. And you can see I need to define the range for these 3 variables. So I click on Define Range, and I have a minimum value of 0 and a maximum of 1. And click Continue. And notice it sets the 0 and 1 for all 3 variables. Now you can have more than 2 categories in a particular variable. In that case, you would just select the individual variable, define range, and set it individually. Under Options, I want to add parameter estimates and the association table. By default, frequencies and residuals are displayed. I'm going to leave them displayed and click Continue. A part of log linear analysis is model building, as you can see the section at the bottom of this dialog. By default, we use backward elimination, but there's also an option for enter in single step. I'm going to stick with the default and use backward elimination. Click OK. And here's the output from log linear analysis. You see I have no missing values here. 2 categories for treatment, gender, and outcome. I move down to cell counts and residuals. I want to make sure that I'm meeting the assumptions here for log linear analysis. And you can see that no cell count, no expected cell count, is below 5. So I didn't violate either of the cell count assumptions. In the goodness of fit tests, you can see that SPSS was unable to calculate that. That's because this model is a perfect fit to the data, because it's a saturated model. And then we move down to the K-way and higher order effects table. So you can see this table is divided into two parts. You have K-way and higher order effects, and then just K-way effects. So to interpret these, we'll start with K-way and higher order effects, and we'll start with K equals 1. And this tells us if removing the one-way effects and any of the higher order effects will significantly affect the model fit. So that would be the main effects of treatment, gender, and outcome, the two-way interactions, so treatment and gender, gender and outcome, and treatment and outcome, and the three-way effect, which would be treatment times gender times outcome. And we can see if they were removed, we have a statistically significant result here, 0.028. As we move down to K equals 2, now we're talking about the removal of just the two-way effects and the three-way effect. And you can see that is statistically significant as well, 0.006. And then at K equals 3, we're just talking about the three-way effect. That's treatment times gender times outcome. And that is also statistically significant at 0.045. The next part of the table, the K-way effects, looks at the one-way effects, the two-way effects, in this case the three-way effect, there's only one, without considering the higher order effects like the first part did. So if we look here at K equals 1, we're talking about what would the model look like if we remove just the main effects. And we have a non-statistically significant result there, 0.695. And then we look at just the two-way effects, K equals 2. So that's treatment times gender, gender times outcome, and treatment times outcome. Just the two-way effects. You can see that is statistically significant, 0.016. And then, of course, K equals 3 is the one three-way effect here, which is treatment times gender times outcome. And, of course, not surprisingly, it matches K equals 3 from the upper part of this table and is statistically significant at 0.045. So then if we look at the partial associations, it's not surprising that we have, treatment times gender is not statistically significant, but treatment times outcome and gender times outcome both are statistically significant. So 2 of the 3 two-way interactions have statistical significance. The only two-way interaction that's not statistically significant is treatment times gender. And then, of course, the main effects for treatment, gender, and outcome, none of them are statistically significant. Then taking a look at parameter estimates. The most useful part of the parameter estimates table is the z-score. So now all these different effects can be compared on a standardized score, and you can see the negative 2.345, the treatment times outcome, is the strongest effect. So we're taking the absolute value here of the z-score, and the highest value, the highest absolute value, would indicate the strongest effect. So treatment times outcome, and also fairly strong, would be treatment times gender times outcome, and gender times outcome. And then we have the backward elimination statistics, and it provides this step summary. So it attempts to delete the highest order effect first, which would be treatment times gender times outcome. And if there's a statistically significant result there, it stops. And that's what happened in this case. It deleted treatment times gender times outcome. There was statistical significance there, so it kept it included in the model. So we go down to the end here, we can see that the goodness of fit test still cannot be calculated because everything was included in the model. So in the case of the analysis of these fictitious data, we would conclude that the three-way interaction, treatment times outcome times gender, makes a significant contribution to the model. And we have a statistically significant finding for treatment times outcome and gender times outcome, but not treatment times gender, and no statistically significant results for the main effects. I hope you found this video on performing a log linear analysis in SPSS to be useful. As always, if you have any questions or concerns, feel free to contact me, and I'll be happy to assist you.